Good afternoon, everyone.
Good afternoon, sir.
Okay, let us start. Remember, we have been learning chapter 5 minerals and energy resources. Today, we shall learn about distribution of minerals and its conservation. Now, I shall share my screen. So, last time we discussed about distribution of ferrous minerals. Now, let us start with the distribution of discussion on the distribution of non-ferrous minerals. Non-ferrous minerals. So India's reserves and the production of non-ferrous minerals is not very satisfactory. However, these minerals, which include copper, bauxite, lead, zinc, and gold, play a vital role in a number of metallurgical, engineering, and electrical industries. So let us study the distribution of copper and bauxite. So this map also shows the distribution of important minerals in India, and here distribution of bauxite. Copper is not here. I will show you another map. Okay, and just see this symbol, and just you will see here also. So let us start. So here we have copper. So I will show you one photograph. So this is a photograph showing copper ore. Okay, greenish in color. So India is critically deficient in the reserve and production of copper. Deficient, okay, in the reserve and the production of copper. That the reserve of copper is meager, small in quantity, and so we need to import copper from other countries. Now let us learn about the characteristics or the properties of copper. See here, being malleable, ductile, and a good conductor. Copper is mainly used in electrical cables, electronics, and the chemical industries. So malleable, capable of being shaped. Malleable means capable of being shaped, bent, or drawn out. Likewise, ductile also can be drawn out into a thin wire. Copper can be drawn out into a very thin wire. And is a good conductor of electricity, and that is why copper is used in making electrical cables, then in electronic industries and in the chemical industries. And figure number 5.5 uh, shows copper mine in Malankan. Okay, Malanskan. So this is open cast mining, and the Balaghat mines in Madhya Pradesh, then Khetri mines in Rajasthan, and the Simbham district of Jharkhand are the leading producer of copper. Okay, Balaghat, Khetri, and Simbham are the leading producer of this copper. And this map shows the distribution of copper and bauxite. The star represents copper. Let's see here. Uh, Here, Khetri, Alwar, Bhilwara, okay here, Bhilwara, Udaipur, then Balaghat, and here Hazaribagh, Singham also here. Okay, let me zoom it. Let's see here. Star represents these copper mines. Okay, and let us continue. Next, we have bauxite. Okay, and so bauxite look like this. Bauxite ore looks like this, and let us read. Though several ores contain aluminum, it is from bauxite, a clay-like substance, that alumina and the latter aluminum is obtained. So, alumina, latter aluminum, that is aluminum mineral, is obtained mainly from bauxite. Okay, so alumina actually it is also known as aluminum oxide. So this is alumina. This alumina is obtained from bauxite ore. It is also known as aluminum oxide, and from aluminum oxide, again we get this aluminum. Okay, aluminum metal. And bauxite deposits are formed by decomposition of a variety of rocks, chemical decomposition. Last time also we learned about the occurrence of minerals, and in that also we have learned. So bauxite deposits are formed by decomposition of a variety of rocks, chemical decomposition, okay, and rich in aluminum silicates. There, just remember, say this, for example, this is a big rock, and here these aluminum silicates, let us say, are present here, and these uh, aluminum silicates or the nodules may be embedded in a soluble rock, and when there is rainfall or when there is running water, then the soluble materials will be removed, and these bauxite ores are okay obtained as a residual material. So this photograph also shows at a bauxite mine. This is also open cast mining. So aluminium is an important metal because it combines the strength of metals such as iron with extreme lightness and also with good conductivity and a great malleability. So these are the important properties of aluminium. So it can combine with the other metals. It can be mixed with the other metals. For example, aluminum alloy can be obtained if we mix with iron, and which is also used in making aircraft body. Then aluminum, this is light, and is also a good conductor of electricity, and it has great malleability. Malleability means capable of being shaped, bent, or drawn out, okay, into a thin wire. So India's bauxite deposits are mainly found in the. This is about distribution of bauxite. Amarkantak Plateau, Mica Hills, and Plateau region of Bilaspur, Katni. So we may have a look of this map again and see here. This symbol, okay, represents bauxite mines, and here Katni in Madhya Pradesh we have Katni, then Amarkantak, then in Chhattisgarh we have Maikala Hill, then Bilaspur, and here in Orissa we have Koraput. Okay, so these are important uh, bauxite mining areas in India. And this pie chart represents production of bauxite state-wise in the year 2016 and 17. And from this, we know that the largest producer of bauxite is Orissa, 49%. of the total production of bauxite in India. Then comes Gujarat is here 24%. Then Jharkhand 9%, Chhattisgarh 8%, the another state Maharashtra also 8%, and remaining other state 2%. Okay, remember Orissa is the largest bauxite producing state in India in the year 2016 and 17. Panchpatmali deposits in Koraput district are the most important bauxite deposits in the state. So this is about distribution of and production of bauxite ore. Up to here, any query, boys and girls? Do you have any question? Boys and girls, do you have any question? Boys and girls, are you connected? Do you have any question? Okay, if you don't have questions, let us continue. Again, let us start with the distribution of metallic, non-metallic minerals. So mica and limestone, this will be learning now. And mica, see this photograph shows mica. Just see the photograph carefully, and I think you will be seeing that very thin sheets are present in the mica ore. Okay, and so with this, let us read the text. Mica is a mineral made of a series of plates or leaves. I think I have shown the photograph. It is made up of a series of plates or leaves. It's split easily into thin sheets. Okay, so form a very thin sheet of mica, maybe say 10 centimeter. We can split many. Okay, hundreds of sheets can be split. And these sheets can be so thin that 1,000 can be layered into a mica sheet of few centimeters high. Mica can be clear, black, green, red, yellow, or brown. So color of mica may be transparent, just like glass. Okay, clear. Then it may be black, it may be green, red, or yellow, or brown, depending on the presence of impurities. Okay, and about the properties of mica, due to its excellent dielectric strength, low power loss factor, insulating properties, and resistance to high voltage, mica is one of the most indispensable mineral used in electric and electronic industries. So dielectric strength, dielectric means actually insulating material or a very poor conductor of electric current. Okay, dielectric means a very poor conductor of electric current or negligible thermal conductivity. And so it has also insulating properties and high resistance to voltage, and that is why it is used in the electrical and the electronic industry. Mica is used in the electrical and the electronic industry. When you open your mobile phone, I think you will be seeing a plate, okay, greenish in color, and on that plate say so many things attached, these ICs and others parts attached, and that thin sheet is made up of mica. Okay, printed circuit board, that is printed circuit PCB, that is made up of this mica. And about the distribution of mica, mica deposits are found in the northern edge of Chotanagpur Plateau, then Koderma, Gaya, Hazaribagh belt of Jharkhand. And so these regions are the leading producer of mica: Chotanagpur Plateau, then Koderma, Gaya, Hazaribagh belt of Jharkhand. And in Rajasthan, the major mica producing is around Ajmer, Nellore, mica belt of Andhra Pradesh belt. Okay, and Andhra Pradesh is also an important producer of mica in the country. Just we may have a look of this map here. Mica, again the star one, this Gaya Hazaribagh. Then again Asmer Biwar is here. Okay, and here in Andhra Pradesh we have Nellore. So these are the important producing regions of mica. And any question, boys and girls? Next we have these rock minerals, and limestone is an example, okay, and the most important one. And limestone is found in association with rocks composed of calcium carbonate or calcium and magnesium carbonates. So limestone is found in association with rocks composed of calcium carbonate or calcium and magnesium carbonate. So here I think you might have seen limestone. So this is a photograph showing limestone, and another photograph, this is also a type of limestone, that is chalk. Okay, and it is found in sedimentary rocks. Limestone is found in the sedimentary rocks of most geological formations, and we know that limestone is a basic raw material for the cement industry and an essential for smelting iron ore in the blast furnace. So these are the uses of limestone. So basic raw material for the cement industry and essential for smelting iron ore in the blast furnace. And about the production of limestone, okay, in the year 2016-17, just see here from this pie diagram, we know that just try to identify, okay, Rajasthan here, 21% of the total production of mica in India is the leading producer of, not mica, it is limestone, okay, is the leading producer of limestone in India. Then Andhra Pradesh and Madhya Pradesh 11%, followed by Chhattisgarh 10%, and Karnataka also 10%, Gujarat and Tamil Nadu and Telangana 8%, then remaining other states 13%. So Rajasthan is the leading producer of limestone. Okay. Till now, any question, boys and girls? Okay, then let us continue. Next, we have so in the box hazard to mining. Okay, so let us read. See, you know, when we have this mining activities, just see the photograph, figure number 5.9. So many smokes and dust particles are generated. That is air pollution. Air pollution due to generation of dust in the mining areas. And because of this, so many hazards are there. So let us read. The dust and the noxious fumes inhaled by miners make them vulnerable to pulmonary diseases. The dust and the noxious fumes. Noxious means injurious, okay, injurious to physical or mental health. Fumes means gases ejected as a waste product. Okay, and these, if we inhale these dust particles and noxious fumes, then this will make the miners vulnerable to the pulmonary diseases. Means pulmonary means related with lungs. So diseases related with lungs. Okay, pulmonary diseases. And the risks of collapsing mine roofs, inundation, and fires in the coal mines are a constant threat to the miners. So, for example, here, this is mainly happen in the case of underground mining. For example, here within the earth surface, mining activity is going on here. People are mining here by digging a tunnel. Okay, and there may be a sharp tunnel here also, and sometimes this roof may be collapsed downwards and killing the miners here. Sometimes through this hole flood water may enter here, and the tunnels here may be flooded, that is inundation. Okay, that also leads to the killing of the people. And sometimes when there is mining here, in the tunnel, then fire may break out and again killing the people. So these are the important hazards of mining. And the water sources in the region, another hazard. Okay, sources in the region get contaminated due to mining. Say for example, here we have a water body here because of mining activity. Okay, these chemicals, unwanted chemicals may be infiltrated towards this water body and just contaminated. Or say for example, if the mining activity is done on the surface here, and this may be coming, okay, flowing down to the water body, the waste products, and thus leading to the pollution. Okay, leading to the pollution of the water bodies, that is contamination is there. Dumping of waste and slurry leads to the degradation of land, soil, and increase in stream and river pollution. And if we dump the waste product in the rivers, okay, in the rivers or the streams, the river pollution is there. And if we dump it on the surface, land surface here, the slurry, the liquids, and the waste matter are dumped on the surface, and again the land will be degraded. Okay, the land will be degraded, and that is why mining is also known as a killer industry. Okay, it affects the miner directly as well as the people indirectly, and that is why mining is known as, okay, a killer industry. Let's see here, killer industry. And next we have this conservation of minerals. Okay, can you tell me what do you mean by conservation, and why conservation of minerals is needed, and what are the different methods of conservation? See, conservation, wise use of something. Okay, wise use of a mineral, that is known as conservation mineral, so that it can last a longer time. And about the why conservation is needed or necessary, it is given here. Okay, let us read this area. The total volume of workable mineral deposits is an insignificant fraction, that is only 1% of the earth crust. The total volume of workable mineral deposit is very, very small, only 1% of the total volume of the earth crust. And we are rapidly using the mineral resources that required millions of years to be created. So to form a particular mineral, it requires millions and millions of years, but we can use it thousands of metric tons of minerals in a day, in a single day. Okay, that means we are using the mineral rapidly, whereas the process of formation is very, very slow. It is also given here. The geological processes of mineral formation are so slow that the rates of replenishment are infinitely small in comparison to the present rates of consumption. So mineral resources are therefore finite and non-renewable. Okay, mineral resources are limited and cannot be renewed. Means cannot be back, just like water resources or forest resources. Okay, and that is why we need conservation of minerals. We need wise use of minerals, because mineral resources are limited, non-renewable. The process of formation is very, very slow, and that is why we need conservation of minerals. Then what are the different conservation methods? What are the different conservation techniques or the methods? So important conservation techniques or methods are here. Let me write here. We can say the first one is innovation. Innovation is one of the method. I said here, a concerted effort has to be made in order to use the mineral resources in a planned and a sustainable manner. Improve technologies, that is innovation of invention of new technologies need to be constantly evolved to allow use of low grade ores at a low cost. So innovation is required, number one. Okay, that is new ideas, new technologies that allow to the use of low grade ores at a low cost, so that the wastage also may be minimized. Another method is the recycling. Okay, recycling and recycling so of metals, that is the using scrap metals, and scrap metal is another method of this conservation of minerals. So for example, we can collect scrap metals, okay, from households, and it can be carried to the again factory, and it can be recycled. So this is another way of conserving mineral resources. Another method is substitution. Okay, another method I will write here. Substitute. Another method is substitution. So whenever possible, we may substitute. Say for example, use of these metal pipes can be replaced by these polythene pipes. Okay, can be replaced by plastic pipes or polythene pipes. Likewise, whenever possible, we may substitute the use of mineral resources by other materials, maybe by wood, maybe by plastics, polythene, or by any other material that can be substituted. So these are the three important steps or the methods of conserving mineral resources. Okay, in addition to this, you can also add one more, that is government policy. Okay, government policy is also very important. Regulation should be there. Okay, laws should be there so that over exploitation of minerals can be checked. That is what we call government policy. So these are the steps for conserving mineral resources. So any question, boys and girls? Okay, if you don't have questions, let us stop here for today. Thank you very much for joining my class. Thank you all.